Welcome to Statistics, where we bring complexity to clarity. I'm excited to have you join me for our third unit, Frequency Distribution. Let's see various terminologies associated with frequency distribution, beginning with frequency. The number of individuals or items occurring in each class is termed as frequency. Frequency distribution, the manner in which the frequencies are distributed over the different class, is called frequency distribution of the character under study. Frequency table, the table indicating frequency distribution, is called frequency table. Class limit, it is the lowest and the highest values of the distribution that can be included in the class. Example 10 to 20, 20 to 30, etc. Class interval, the width of the class, that is the difference of the upper and lower limit of the class, is known as class interval. For example, 20 minus 10 is equal to 10. Here, 10 is the class interval of the class 10 to 20. Class midpoint. It is the value lying half the way between the lower limit and the upper limit of a class interval. That is, lower plus upper limit divided by 2. For example, 10 plus 20 divided by 2 is equal to 15. Here 15 is the class midpoint of the class 10 to 20. So these were the various terminologies associated with frequency distribution. Now let's see the objectives of frequency distribution. To condense the mass of data in such a manner that the similarities and dissimilarities can be easily understood. The next objective is to enable statistical treatment to the data collected. Proceeding with the procedure to form frequency distribution. So the first step is to find range of the data. Here range is equal to highest value minus lowest value, which can be abbreviated as H minus L. Step 2 is fix the number of classes. The number of classes should be preferably between 5 and 15 and should not be less than 5 or greater than 30. Approximate number of classes K is equal to 1 plus 3.322 log n according to Sturgis rule. Here capital N is equal to total number of observations. Step 3 is to fix the class interval, that is Ci is equal to range divided by number of classes, or can be abbreviated as H minus L divided by K. Step 4 is to arrange the classes in ascending order of magnitude. Step 5 is to pick the values of observation and make tally mark against respective classes. Step 6 is to find total tally mark of each class, which will give the number of frequencies in the respective classes. So, the procedure to form frequency distribution consists of 6 steps. In the first step, we have to fix the range. In the second, number of classes. Third, class interval. Fourth, arrange the data in ascending order. Fifth, make tally mark against respective classes. Sixth, find the total tally mark of each class, which will indicate the number of frequencies of the respective classes. Now let's see the graphs of frequency distribution. Histogram, it is a bar diagram which is suitable for frequency distributions with continuous classes. The width of all the bars is equal to the class interval and the heights of the bars are in proportion to the frequencies of the respective classes. In this diagram, bars touch each other, but one bar never overlaps the other. Let's see the diagram. The width of the bars corresponds to the class intervals and the height of the bars corresponds to the frequencies of the particular class. Also, the bars touch each other, but the two bars never overlap one another. Frequency polygon. The midpoints of the tops of the adjacent bars of histogram are joined in order by a straight line, then the graphs of lines so obtained is called a frequency polygon. For example, we denote here the midpoints of the bars and join them in order with the help of straight line, then we get frequency polygon. Frequency curve. It is a graphical representation of frequencies corresponding to their variate values by a smooth curve. A smoothened frequency polygon represents a frequency curve. So here the midpoints are denoted and they are joined with a freehand smooth curve, and it is called frequency curve. Ogive or cumulative frequency curve. It is a graph plotted for the variate values and their corresponding cumulative frequencies and joined by a freehand smooth curve. The curve is S-shaped. There are two methods of constructing ogive, less than and more than method. In the less than method, we start with the upper limit of classes and go on adding the frequencies. And in more than methods, we start with lower limit of the classes. So this is the plot of less than and more than ogives. Here, this line indicates the less than ogive and the red line indicates the more than ogive. Also, the first method gives the rising curve, and the second method, that is more than type, gives a declining curve. And the midpoint of the two curves gives the median of the data set. There are two types of frequency distribution: discrete frequency distribution and continuous frequency distribution. Let's see the methods of classifying the data according to class interval. So there are two methods, exclusive and inclusive method. Exclusive method. In this method, the class intervals are so fixed that the upper limit of one class is the lower limit of the next class. Example, 0 to 10, 10 to 20, and so on. Here, 10 is the upper limit of class 0 to 10, which becomes the lower limit of the next class. The data observed up to 9.99 would be included in 0 to 10 class, while 10 or greater than 10 will be included in 10 to 20 class. Usually this method is preferred for continuous type of data. Next is inclusive method. In this method, the class intervals are fixed in such a manner that the upper limit of one class is included in that class itself. For example, 100 to 199, 200 to 299, and so on. The value of 100 and 199 will be included in the class of 100 to 199. This method is preferred for discrete type of data. Thank you for joining me on this journey through our third unit, frequency distribution. If you found this unit helpful, don't forget to like, share and subscribe to Statistics for more insights and clarity on statistics. Your support helps us continue creating content that makes complex topics simple and accessible. Follow us on Instagram and LinkedIn.